Okay, this is AP Stats, Quidio number 5. Basic question. In which of the following situations can you safely use the methods of inference for a population proportion for a significance test? Explain your answers. So for A, you tossed a coin 10 times in order to test the hypothesis P equals 0.5, that the coin is balanced. So the methods for inference for a population proportion for a significance test, you have to do n times p is greater than 10 and n times q, q being the complement of p, is greater than 10. And then also the population has to be larger than 10 times the sample size. And it has to be a random sample. So if it doesn't say SRS, you have to assume it says SRS. So for A, 10.5, which would be the n times p, is 5, which would be less than 10. Therefore, you cannot safely use the methods of inference for a population proportion for a significance test. So the answer for A already would be no. And also, the NP is equal to the NQ because the complement of 0.5 is 0.5. So they would both NP and NQ would be less than 10. For B, 200 times 0.99 gives you 198, which is much greater than 10, so you're okay there for n times p. And then n times q, the complement of p, would be 200 times 0.1, gives you 2, therefore you cannot safely use the methods of inference for a population proportion for a significance test. So the answer right there would be no because of the complement one. For C, 20 times 0.5 is 10, which is the n times p, and the complement of 0.5 is 0.5 again. So NQ is also the same. SRS is stated. 20 times 10 is less than 250. So 200 is less than 250, which is 10 times the sample size. So yes, you can safely use the methods of inference for C and C only. For the advanced question, for each of the following situations, state whether a type 1, type 2, or neither error has been made and explain. A says a bank wants to see if the enrollment on the website is about 30% based on a small sample of customers, and it rejects the null hypothesis. Later, the bank finds out that actually 28% or 0.28 of all customers enrolled. So for A, rejecting the null hypothesis is a type 1 error. And HO, the null hypothesis, P equals 0.3. HA would be the alternative hypothesis, P is greater than 0.3, whereas the actual results were 0.28 equals P. So 0.28 is less than 0.3. Therefore, the alternative hypothesis would not be true. For B, a student tests 100 students to determine whether other students on the campus prefer Coke or Pepsi and finds no evidence that the preference for Coke is not 0.5, meaning there's not a preference. Later, a marketing company tests all students on campus and finds no difference either. So, neither error has been made because there is no difference. It's 0.5 for both. C, a pharmaceutical company tests whether a drug lifts the headache relief rate from the 25% achieved by the placebo. The test fails to reject the null hypothesis because the p-value is 0.465. Further testing shows that the drug actually relieves headaches in 38% of people. So this would be a type 2 error, because for C, we failed to reject the null hypothesis, which is a type 2 error. The p-value was 0.465, and the actual was 0.38, and we started at 0.25 with the placebo or the control group. The AP question, it wants to determine whether drivers are significantly more distracted while driving when using a cell phone than when talking to a passenger. It involved 48 people, 24, so two groups of 24. And here I made a chart. So we start with 48 people, broke it into two groups, 24 driving the simulator while using the phone, and 24 talking to a passenger while driving the simulator. And then out of these 24, 7 missed the exit, which gives you that percentage, and 17 got the exit, giving you that percentage. And this, I said, was PC. And then the other 24 is over here. Only 2 missed the exit. There's your percentage. And 22 got the exit. There's your percentage. And I called this one PT. So for A, I said this study would be classified as an experiment because we applied treatment to the groups and not just observed studies or subjects. Drivers were assigned tasks rather than just recorded. So because we made that difference, it's considered an experiment and not just an observational study. For B, you had to state the null hypothesis and the alternative hypothesis. So here, HO would be PC equals PT, when PC is the probability of people while using cell phones, and PT is the probability of people while talking to a passenger. And then HA would be PC is greater than PT. And then C, 2 sample Z test. In order to do that, N times P has to be greater than 10, and as you can see, I tested that, and it is. The complement Q times N has to be greater than 10, and as you can see, it isn't. And then, because it's a 2 sample Z test, you're going to have 2 of these. So the other 2 are right here. As you can see, the other NP does not pass 10 as well. So no, all the conditions are not met. In order for the conditions to be met, N times P has to be greater than 10 and N times Q has to be greater than 10. It states drivers were randomly assigned, so SRS is assumed based off of this. The sample size should be small in comparison to population, therefore 10 times N, sample size, should be less than the population, which is met because 10 times 48, 48 was our original population, equals 480, which is less than the population of drivers overall. That's it.